I don't know what's happening. I just got an error message on my screen. Okay, sorry. But we're going to be looking at positive and negative intervals of functions. Okay, so just kind of as a quick little, you know, when we talk about positive numbers versus negative numbers, I'm not saying anything new here, right? Positive numbers are greater than 0. Negative numbers are less than 0. Okay, so that's what we're going to be looking at today. When is a function positive? When is a function negative? Easy peasy, right? So let's take a look at a graph. So this graph is given to us. Oh, I got to center it up here. And they want us to determine the intervals. We're going to use interval notation, which remember are x coordinates, over which the graph is positive and negative. So I have my 2 colored pencils here. I'm going to use pink for positive. And these were just the 2 that were sharpened. And I have this like bluish, greenish, tealish color for negative. Doesn't matter. I'm just using 2 different colors. So let's start by writing this down. I want to know where f is positive. And I want to know where f is negative. Well, let's step back for a moment. If f, remember f means y, right? So I'm basically saying where is y positive? Well, we already just said greater than 0. So I want to know where the y is positive, and y values are positive above the x-axis. This is a very fancy way of saying when is your graph above the x-axis. So I'm going to use my pink pencil and just shade on the graph when it is above the x-axis. Well, I'm going to do the same thing. I'm going to write the answer later. If I want to know where f is negative, remember f means y, and y is negative. The y coordinates are negative below the x-axis. Well, and I said I'd use that turquoise pencil for that. So I've just shaded in those intervals, and I'm still, just like we did the other day, I'm going to go translate that information to the bottom of my paper, if that helps. You know by now if that helps or does not help you. If you don't need it, then don't do it. So we just want to write the intervals where my graph is pink versus where my graph is teal. What I want to highlight before we start is where we change, right? Look to see where I change from teal to pink. Oh, that's an x-intercept. Oh, changes from pink to green. That's another x-intercept. Oh, changes from green to pink. Pink, that's my x-intercept. So the other day, transition points for us were maxes and mins when we were talking about increasing and decreasing. Well, today, our transitions occur at the zeros, or we know those are also the x-intercepts. So for us, x-intercepts are going to be important information. So I have to eyeball this a little bit. Looks like this x-intercept is at x equals 3. I'm going backwards. This one is at -1, and this one is at -3. And that's all we need. And now we can go in and write our answers. I'm starting with the positive above the x-axis. That's the pink. That occurs from -3 to -1, and then again from 3 to infinity. Now, I am definitely only using parentheses here. Why do I not get to include the -3? Because I'm not above the x-axis there, I'm on the x-axis there. So we want to make sure for this question we're only using parentheses. And then I'll answer this, the last one. When is it negative? That's when I'm turquoise, and that's from -infinity to -3, union -1 to +3. Okay. So very similar to what we did a while ago. I don't even remember what day it was. 7.6, when we were talking about increasing and decreasing behaviors, but now we're just talking about above and below. That's what it means for a graph to be positive or a graph to be negative. Awesome. Let's grab our graphing calculators. Okay. So it says use a graphing calculator to graph the function. And so I'm using an 84, but we talked about graphing. We've talked about it all year. So I'm going to go to my y1 and I'm going to type in my -0.5x cubed, get out of the exponent, minus 3x squared plus 4. Now, I'm going to just zoom 6. When I hit zoom and then the number 6, it just takes me back to a standard viewing window, which goes from -10 to 10, -10 to 10. If you have an Inspire, it's not zoom 6. You can change your window a couple different ways, and we can certainly talk about that. But here's my graph. And, it's not a great window because I don't see everything. I feel like I see everything side to side, but I feel like I want to look down a little bit lower. So I'm going to change my window just a little bit, and I'm going to hit window. On the Inspires, you're hitting menu and then number 4 and number 1. So on the Inspire, menu 4, 1, which will pull up a very similar question set. I don't mind the X's, right? That's going from -10 to 10. I want to go lower. So I'm going to go down to my Y min, and maybe I'll go to -15. I don't know if that's low enough. I think it's got to be close. Oh, perfect. Okay. All right. So what I would like to do is I'd like to translate this onto my paper. So I'm going to slide my calculator over here. Sorry about that glare. Let's move that out of the way. Okay. So let's take this. Now, there's no y-axis, no y scale, I should say, here. So I'm not worried about the y values. But let's take some important information and translate it over. It looks like this graph crosses the x-axis 1, 2, 3, 4, 5, just shy of -6, somewhere between -1 and -2, and then somewhere around x equals 1. And then it looks like we've got like a high point here and like a low point maybe here. I don't know. I'm just trying to translate some of the important information, but I'm not worried about the y values because there's not any labeled there. So I'm just going to take my pen and just kind of draw in what I see on my calculator. It doesn't have to be perfect. I'm just going to try to match it a little bit. And I'm going to give you time to do that. And while you're doing that, is anyone having trouble with their calculator? I don't want to say trouble. Does anyone have any questions? You let me know. Same thing, we talked about graphing yesterday on Desmos, so make sure, if you're using Desmos, you know how to type that graph in. All right. Someone shout out or type in the sidebar if I'm going too fast. So let's start answering these questions. Sketch the graph and determine the intervals over which f of x is greater than 0. All right, well, slide back up for a second. Remember how we said greater than 0? That means positive. So it's really the same question we just answered. They want to know where f of x, remember f of x means y, is greater than 0, and greater than 0 means positive. So they really want to know, when is y positive? Well, another way to ask that is, where is the graph above the x-axis? It's the same question we just answered. I'm going to use my pencil to highlight on my graph. So I'm above the x-axis here. The second question is the exact same thing. When is y? Now it says less than 0. Less than 0 means negative, and negative means below. the x-axis. So instead of saying when is f positive, when is it negative, they just wrote it as more of an inequality. Greater than 0 means above, less than 0 means below. So I'm going to use those same two colors to just highlight on my graph. And again, if it helps, then go ahead and translate that information down to that one-dimensional image down at the bottom, if it helps. Excuse me. So now we're in the same place that we were on the previous slide. We have a graph, we've shaded our regions, but now we need to look at the transitions. And we need to know where we're changing from above to below or below to above. So I need to go find those x values. I need to go find those zeros. I'm not going to eyeball it. I was given the gift of a graphing calculator. And when we're given a graphing calculator to use, we should come up with, the best answers that we can. So let's go back to our calculators. I'm going to just put this right in the center here. I know, sorry. Got some glare. Okay. Oh, because it's not. Okay, there we go. So I want to go find those 3 zeros or x-intercepts. Last week we were finding maxes and mins. Yesterday we talked about how to find maxes and mins. Same process. On this calculator, I'm going to go to that calculate menu. So I'm going to hit second trace. That's what we did yesterday. But yesterday we were going to numbers 3 and 4 for maxes and mins. Now I need the 0. So let's go to number 2. On the Inspire, for those of you that have the Inspire, you're hitting menu and number 6 for analyze graph, and you're going to number 1, which is 0. Okay. So again, on the 84, I hit second trace and I found 0. On the Inspire, I'm hitting menu 6. All right, but either way, we need to go find 3 zeros. I'm going to start with this one way over here. We can, same question, by the way, from yesterday, left bound. So you can hold that down. We want to go to the left side of the 0. So I go to the 0 and I go to the left a couple more clicks and hit enter. Then I go to the right of that 0. So it was asking again for the lower bound and the upper bound, and it's just setting us up for an interval. You're just telling the calculator where to look. Now it's asking me to guess. We never guess. So we just hit enter again. So just like us finding the max or the min, we go on the left side of it, then we go on the right side of it, and we hit enter. And at the bottom, it's going to give us those coordinates. Now we know the y coordinate should be 0. And if you look, it is 0. It just doesn't look like it. This is scientific notation. So it's really saying negative 0.00000000003. So yeah, that's 0. It's the x coordinate that I really want, which is to the nearest thousandth, negative 5.759. I just wrote that on my graph. So this 0 is at negative 5.759. Remember, those of you using Desmos, all you need to do is graph the function. And then once you click on the function, it gives you the coordinates of every single max, min, 0, y-intercept. So it'll just be a little bit faster. Okay. Let's go find the second one. Same procedure. I'm going to go second trace down to number 2. I'm going to go over to this 0. I'm going to start by going to the left a little bit, couple clicks, hit enter, then go on the right side of it a couple and hit enter. And then it says guess, and I'm going to hit enter again. Again, doesn't surprise me, the y value is 0. The x coordinate is negative 1.305. Mathematically, this is not a difficult problem. It's just taking us a while to get all of the information that we need. All right, third one, and I'm going to show you something a little bit different this time. Still going second trace number 2. But for those of you that are struggling a little bit with the left side, right side, you can just type in numbers. I think we could all agree that this next x-intercept is around 1. So maybe we tell the calculator to look between 0 and 2, or 0 and 3, or 0 and 10. It doesn't matter. So when it says left bound, I'm just going to type in a 0 and hit enter. This is an alternate way of finding the 0. Then it says right bound. I'm going to hit like a 3. I don't know. I'm saying it's clearly between 0 and 3. And I hit enter. And so it still sets up those arrows at the top. So the calculator is saying, I'm going to go find the 0 that's in there. Do we want to guess? No. So we hit enter again. And we get 1.064. So I showed you two different ways to do that. One is to go to the left and then to the right. Or you can just type in two numbers that are on either side. Okay. Awesome. How are we doing out there? Questions, comments? All right. Well, let's go ahead and write our answers. Because now that we have those x values, we're ready to write those intervals. I clearly didn't leave myself a whole lot of room. F of x is above the x-axis from negative infinity to negative 5.759. And then again, whoops, parentheses, sorry, from negative 1.305 to 1.064. And I apologize, I don't mean to cram all that in there. That's poor organization on my part, isn't it? So once I had my zeros, just like on the last slide, now I'm just going to write those two pink intervals that I had. When is f of x less than 0? Well, that's when we're turquoise, which is from negative 5.759 to negative 1.305, union, and then again from 1.064 to infinity, all the way to the right. Okay. Good. Box that in. That way you can clearly see that. So I'm sorry about my mess there. How's that look for us? Okay. Go ahead and put your calculator aside because we're done with that for now. And let's take a look at the next question. So the first slide, they gave us the graph. The second slide, we used a calculator to draw our own graph. And now this third one says, sketch the graph. No calculator. That's all right. We don't need a calculator to do this. This is what we were doing a few weeks ago. Well, up until just last week. Sketch the graph. Oh my gosh, it's already factored for us. And once we see factors, we know we can find the zeros, which is awesome because isn't that what we needed back here? Were the zeros? Perfect. We're going to find the zeros. If x minus 2 is a factor, then x equals 2 is my 0. So there's my x-intercept. If x plus 4 is the factor, then x equals negative 4 is my 0. And then my last 0 is at negative 1. Oh, awesome. So we certainly didn't need a calculator for that anyways. It's already factored, which means we have all three of our zeros. And now if I want to connect these zeros, we need to talk about the end behavior. Right? This is old stuff. This is an x to the first. This second factor is to the first. And the third factor is to the first. So I have x times x times x, which is x cubed. And we know the graph of x cubed is going down on the left and up on the right. So I've got my three zeros. And I know my graph is going down on the left and up on the right. I switched to a pencil so that if I needed to erase, I could. None of these factors have any higher power, so we know we're going to pass straight through. So starting down here, I'm going to pass through negative 4. I'm going to turn around and pass through negative 1. And I'm going to turn around and pass through positive 2. And I missed that second arrow, which I typically do, and that's okay. And if you need to, or if you want to, you can go back over in a pen and smooth it out, or just smooth it out with your pencil, right? There's our graph. We didn't need a calculator for that. Perfect. All right, step number 1, sketch the graph. Done. Number 2, use your graph to solve the inequality. Take this factored polynomial and tell me when it's greater than 0. Okay, so first of all, the left side, that's our graph. They want to know when the graph is greater than 0. We've already said greater than 0 means above the x-axis. Oh, that's it? That's all they're asking for. When is this function greater than 0 means when is this graph above the x-axis? I was using pink for that. I'll still use pink. So they're just asking when is the graph above, not above and below. Perfect. We already have our zeros. If it helps, I'm going to continue doing this. If it helps, translate your shading down to the bottom and go ahead and write your x values there from -4 to -1 and then from 2 on. So my answer is from -4 to -1 in parentheses, union 2 to infinity. They only asked that one question. When is the graph above the x-axis? And we're done. This is how we're tying everything into what we did over the last few weeks. If you have the factors, you have the zeros. And if you have the zeros, then you can determine where your graph lives. Awesome. How are we doing out there? All right, flip it over. You interrupt me at any time. Okay, let's do another one. It says use a graph to solve the inequality. So here we are, solving inequalities like you solved inequalities in Algebra 1. They may not have looked like this. So if I want to know when this whole thing is less than 0, let's go graph this function. And less than 0 means I want it to be below the x-axis. Awesome. So if we want to graph a function, let's go find the zeros. Great news. We already have the factors. So we'll set each factor equal to 0. So x minus 1 equals 0, x plus 7 equals 0, x minus 6 equals 0. So I've got x equals 1, x equals -7, x equals 6. There's my zeros. Let's go put them on the graph. So I've got 3 x-intercepts. Here's where, this is a good little reminder, this factor was to the 3rd power, which means I'm going to wiggle, remember that, we're going to wiggle through the x-axis at x equals 1. This factor was squared, so this one's going to bounce, right? Now it's starting to come back to us. And then this one was to the 1st, which means it's going to pass straight through, like a line would, right? Well, before I do anything else, I better talk about end behavior too. My first factor was cubed. My second factor was squared. And my third factor was to the 1st. Right? I just got rid of like the 1, the 7, and the 6. So I have 1, 2, 3, 4, 5, 6 x's. We know an even powered degree, both sides will open up, or yeah, both sides will go up. All right, so this side is opening up, this side is going up. Let's see, at -7, we're going to bounce. So I'm going to come down here and bounce off of -7. The next 0 is at +1, and we said we want to wiggle through 1. So it doesn't matter necessarily how high we go. I purposely didn't put a scale there, but I need you to slow down and kind of wiggle through at x equals 1. And then I want to pass straight through 6, which means I just need to turn around and go straight up. Oh, that's probably the first time ever I've hit my arrow. And again, if you want to go in and smooth that out with your pencil, whatever you need to do, that is a pretty darn good graph. All right. At any point, please tell me if I'm going too fast, if I need to slow down. Without seeing you in person, I can't tell who's still writing things down. From the very beginning, we said we want to know when this graph, oh, it's right here, is below the x-axis. And there's only one portion that's below the x-axis. I just highlighted that in my teal color. I'm kind of covering this up because this is another question. I didn't leave myself a lot of room. But this graph is below the x-axis between 1 and 6. Not including the 1 or the 6 because the graph is on the x-axis there, not below. Okay, so there's my answer to that first question, and I'm sorry I took up so much room there. Okay. What happens if I make a slight change? It says now use your same graph to solve this new inequality. Well, what's different? The function is not different. There's still a 0 over there, but now instead of just less than, now it says less than or equal to. Remember, less than 0 means below the x-axis. Equal to 0, gosh, we've been doing that for years. When we set a function equal to 0, we're finding the zeros or the x-intercepts. So that's when we're on the x-axis. So below, less than, equal to means on. So they're basically saying, we don't just want to know when we're below the x-axis, we also want you to include when we're on the x-axis. Well, we're on the x-axis here, here, and here. Right? Don't forget this guy out here, he's on the x-axis. Or she. Sorry. All right, so here we go. Let's start with this one. I want to write this interval from 1 to 6, but this time I get to include the 1 and the 6 because, well, they're equal to 0 there. The question is, how do we also then say that this is part of our answer? I'm going to use that union, and notice I'm writing backwards. This is not an interval, right? It's just a single number, and we've done this before. It's just a -7. And so we can put it in those brackets, and that's just our way of saying we want to include -7 in our answer. Kind of wild, isn't it? So we need to start looking at, does it say less than, or does it say less than or equal to? Because if it says or equal to, that's when we also include those zeros. Start using some brackets. Awesome. How'd we do? Questions? Okay. Gosh, look at how much time we spent coming up with the graph here. And it's a beautiful graph, right? I think you'd all agree with me. It's a nice looking graph. My question to you now is, what if you didn't want to draw the graph? What if you couldn't draw the graph? Do we need the graph to solve an inequality? I mean, we might want it, but do we need a graph? And the answer is no. What we're going to start doing over the next, well, today and then tomorrow and Thursday is solving the inequality algebraically. We're going to use what we call a sign chart, and a sign chart is just a fancy way to say we're going to use a number line, right? The x-axis is a number line. And we're going to solve the same one we just did. We already have the answer, right? I already know this. It's from 1 to 6. But I'm going to show you how we can do it without talking about the zeros and do they wiggle, do they bounce, what's the end behavior. We're going to do this without doing any of that. But what we still need are the zeros, okay? So the first thing we're going to do is we're going to find the zeros, which we already have, and we're going to put them on a number line. And remember, the number line is really just the x-axis. All right, so we already have those zeros. They are at x equals 1, x equals -7, and x equals 6. Draw yourself a little x-axis. Don't put a million tick marks on it. Put 3 tick marks on it. -7 comes first, then 1, then 6. Essentially, what I'm about to do is just draw the x-axis and not worry about the shape of the graph, okay? Now, you might want to, for what we're going to do tomorrow, you might want to go ahead and just put them and just kind of jot yourself a little note that these are the zeros. That's where the graph is on the x-axis. And now what we're going to do is we're going to find the sign, S-I-G-N, of the numbers between the zeros. And I'll explain how we're going to do that. But essentially, I know that the graph might be transitioning from positive to negative at these 3 numbers. So essentially, I'm just going to check between those numbers on either side of them. How am I going to do that? I'm going to plug numbers in to the function. Now, I'm not actually going to do the math. I just want to know the sign. Let me use my pink pencil as a highlighter. I just want the sign of the numbers in between. All right, so here we go. I'm going to start here between 1 and 6. You can pick any number you want. I'm going to pick a 2. Pick any number you want. You just can't use 1 or 6. So I'm going to pick a 2, and I'm going to plug that 2 in for every x. But I am not going to do the math. Watch this. 2 minus 1 is 1, which is a positive number. And when you cube a positive, it's still positive. I'm just going to write that down. Then I'm going to plug the 2 in here. 2 plus 7 is 9, which is positive. And when you square a positive, it's still positive. Oh, you know what, by the way? If this is squared, this is always going to be positive, isn't it? All right, let's plug the 2 in here. 2 minus 6 is -4. I didn't write down -4. I just wrote down negative. This is a sign chart. All I need is the sign of the answer. So I have a positive times a negative, which is overall a negative. Let's do it again. Let's pick a different interval. Let's go over here. Something to the right of 6. I don't know, I'll pick a 7. 7 minus 1 is a positive number, and when you cube it, it's still positive. This second piece I already said was always positive because it's going to get squared. 7 minus 6 is a positive 1. I don't care that it's a 1. I just care that it's positive. And a positive times a positive times a positive is a positive. So this is, I know I'm going slow, but this is saving us the hassle of, does the graph wiggle? Does it bounce? What's the end behavior? Let's go over here. Something between -7 and 1. I like 0, honestly. When I plug in a 0 here, I get a negative. And when you cube a negative, it's still negative. This second piece is always positive. When I plug in a 0 here, I get a -6. So negative. And putting the negatives together, I get a positive times another positive is a positive. Awesome. Let's go back here. Something to the left of -7, like -10, -8. You pick one. I'll pick -10. -10 minus 1, still negative. Cube it, still negative. Second piece, AP, always positive. Third piece, -10 minus 6 is still negative. And so we get overall a positive again. Now, some of you might be going, you know what, Mrs. Patton, I'd rather just draw the graph. And you know what? That's okay, because you're right. This graph was easy for us to draw. But tomorrow we're going to start looking at some things that you might not know what the graph looks like. So this is probably a good bet for us because it's always going to work. Well, the question is, what the heck did we just do? Well, what we've done is we've just said the graph is positive, the graph is positive, the graph is negative, the graph is positive. We've basically just taken the information from the graph and just kind of kept it pretty linear here. So what did they want for us to find? They said, when is the graph less than 0? When is it negative? When is it below? My graph is negative between 1 and 6, which we already knew that, right? We did it on the last slide, but we just looked at it a little bit differently. Okay. Awesome. Hey, I am going to do the last one. And if you need to go because class is over in a minute or two, then you need to go. But I'm going to finish the last one. So if you want to hang out with me and do it, let's do it. Okay. One more, just so we can see another sign chart. It says solve the inequality. Write your answer in interval notation. Now, the big difference here is that it's not factored already for us. And it's not, doesn't have a 0 on one side. Everything else we've done was less than 0, greater than 0, less than 0, greater than 0. We can fix that. Let's just move these over. So I have 2x to the 4th minus 5x cubed minus 3x squared. I still have my greater than symbol, but now there's nothing left over there. So there's my 0. That's what I needed. And now that I see that it says greater than 0, that means I'm looking to see when it's above the x-axis. When's it positive? Okay. Well, we want to make that sign chart, so we need to find the zeros. Look at your list on the last slide. Find the zeros. How do we find zeros? We factor. Find zeros, so we need to first factor. Look for that GCF first. Perfect. Look at that. All three of those terms have an x squared. Let's pull that out. And that leaves me with 2x squared minus 5x minus 3. Love it. We can continue to factor. Look at that quadratic trinomial. Let's see if we can factor it anymore. I believe we can. I'm doing a little guess and check in my head. Let's make that x minus 3 and 2x plus 1. That should do it for us. Spend the time to make sure that's factored correctly, because if it's not factored correctly, then it's not going to go so well for us. Okay. If you want, you see that x squared there? Remember, that's like x squared, right? So it's kind of like x minus 0. So x equals 0. There's one of my zeros. X equals negative 1/2, and x equals 3. There's my 3 x-intercepts, or my 3 zeros. So make that number line, and let's put our zeros in numerical order. My negative 1/2 comes first, then my 0, then my 3. Notice I'm not spending a lot of time here, like trying to get them equally spaced. And also notice I'm not putting any more tick marks on here. I am specifically, if I have 3 zeros, I am only putting those 3 numbers on there because I don't want the clutter. I don't want the confusion. Okay. All right. So this is where my graph was equal to 0. To make the sign chart, we're just going to go plug in numbers between all those zeros. I'm going to start in here. Something between 0 and 3 is 1. Now look at this one. It's going to be squared. So it's always positive. So great news. All of these intervals are going to start with a positive. That saves us time, doesn't it? All right. So again, didn't mean to get sidetracked. I'm plugging in a 1. When I plug in a 1 here, I get 2 plus 1. Well, that's a positive number. And when I plug in a 1 here, 1 minus 3, well, that's a negative number. So positive times a negative, overall negative. Let's go here to my, bigger than 3. I'll pick a 4. Again, I already have my positive. When I plug in a 4, this is 8 plus 1, which is 9. That's positive. When I plug in a 4 here, I get a positive 1. And a positive times a positive times a positive is a positive. I know some of you are hanging out with me, and I appreciate it, so I'm going to speed up a little bit here. I need to pick a number. Ooh, this is tight, between -1/2 and 0. I normally don't write this down, but I'm going to plug in x equals, I'm going to pick -1/4. I just wrote that note to myself because it's not maybe as obvious. So again, I have my positive. If I plug in a -1/4, well, I get a -1/2 here. Plus 1, that's a positive. And negative anything -3 is still negative. Whew. Okay. And then I'm going to go back here and plug in something, I don't know, like -2, -1, -10, any number to the left. I'll plug in a -2. Again, I have my positive. This will give me a -4 plus 1. That's still negative. And then this will still be negative. So again, I'm plugging in a number for x, and I just need to know if the answer will be positive or negative. So my two negatives multiply together, get a positive, and I still have that positive. Woo-wee! So what were they asking us to find? They are asking us to find when our graph is above the x-axis. And that happens here and here. Let's go write those intervals. From -infinity to -1/2. And then I pick up again from 3 to infinity. Okay. Awesome. So thank you for sticking it out with me. I am available to stick around for a few questions.